Today's lesson is on decimals to fractions. We're going to be looking at centimeters. The thing I like about centimeters is that there are 10 tick marks in between each centimeter here. It's very That's just 0.1 of a centimeter. It's 1/10 because there are 10 of them. And if we just have one decimal place here, I can write that over 10. Past it. There are 2 tick marks past this, right? So this would be 1.2 centimeters. I'd write that as 1 2/10, right? Because it's just one decimal place, and I put that over 10. This can be reduced, though, because 2 goes into both 2 and 10 here. So this would be 1 1/5 centimeter. Let's keep going. Let's say we're at 2 centimeters, right? And we're 3 tick marks past. This would be 2.3 centimeters. I could also write that as 2 3/10 centimeters. I can't reduce this one because 3 and 10, they don't have a common factor, right? Whereas let's say we're 4 tick marks past it, right? This would be 3.4 centimeters. Or I could write as 3 4/10. Here again we see these are both even, and so just like before I can reduce it, this would be 2/5 centimeters. Now you'll notice with each of these they have this longer tick mark in the middle, right? Once you get to here, you're halfway. You're at 0.5. You could write that as 5/10 or 1/2, right? So this is all with just one decimal place. You can write it over 10 and sometimes reduce, right? I'm going to show an example, right? A very common example, or maybe not as common nowadays. This is a check, right? People used to write checks a lot. Now you don't see as many checks. You'll notice that the dollar amount, they have 2 decimal places. A lot of prices of things, and when you're dealing with money, it goes out to 2 decimal places. So 0.22, they write that as 22 over 100, right? So this deals with place value, right? We had some dollar amount in the hundreds here, right? Tenths, hundredths. So when you're dealing with money, it goes out to the hundredths, right? So on that check, we had 0.22 hundredths, and they wrote that as 22 over 100, right? But this keeps going. You could have thousands, 10,000s, right? Let's say, for example, I had 0.125. This is a very common decimal that you might see, right? I wouldn't write this over 100. Because there are 3 decimal places, it's in the thousands. I write it over 1,000 with 3 zeros. So however many decimals there are, that's how many zeros you have. Now both of these can be reduced. 22 over 100 can be reduced to 11 over 50. I just cut them both in half, right? I can't reduce this anymore because 11 and 50, they don't have a common factor. 11 is a prime number, right? Let's take a look at this. Now, instead of just trying to cut something in half, especially because this is odd, I'm noticing 125. I know that 25 goes into that. 25 goes into 125 5 times. Goes into 1,000 40 times. I can even reduce this further. This would end up being 1/8. Right? So when you have a terminating decimal, you can put it over however many digits there are. That's how many zeros there are. And reduce. But here's my next question. What about repeating decimals? Right? Here we dealt with terminating decimals. What about when we have repeating decimals? say for instance we had like 0.1 repeating. So 1, 1, 1, 1, 1, right? I can just write that as 1/9. Say we had 0.2 repeating. I can just write that as 2/9. Now, 0.3 repeating, again, I could write it as 3/9, but that can be reduced to 1/3. You can divide both these numbers by 3, right? So you might even remember that 1/3 is 0.3 repeating. Whereas 0.4 repeating, again, I would just write that as 4/9. I can't reduce that, right? 0.5 repeating is 5/9. And then when we get to 0.6 repeating, with 6/9, we see that we can reduce that one as 2/3. And you might remember that 2/3 is 0.6 repeating, right? This would continue then with just 0.7 repeating being 7/9, and so on. So we covered terminating decimals, repeating decimals. In the next video, you're going to see what happens when there's just one decimal repeating. Thanks for watching.